All right, hello everyone, and welcome to our CS230 final project presentation on predicting the popularity of rap and hip hop songs. So here's a little presentation outline. First, I'll take you through our project motivation here. So music is a very large industry and can be seen in cultures throughout the world, um, very prevalent. And also music is very lucrative. It's a big business, generates a lot of revenue every year. And as you can see from this graph, streaming is becoming more prevalent and more influential in the world. So we decided to focus our project on machine learning on music. And ideally, this is kind of what a high level representation of what our machine learning model would do. It would take audio features as an input, run it through our algorithms, and output a predicted song popularity. Next, we'll move on to our data acquisition. So to acquire our data for our model, we turn our attention to Spotify. This is because it's one of the largest streaming platforms out there and has a large library that we can pull data from, and it's very prevalent in the industry. Also, Spotify has an API that can be used with Python to get a lot of data from songs and use for our model. So here's some of the input features that we acquired from the Spotify API that we used. These are all calculated through algorithms within Spotify and give us singular numbers as inputs for our model. And for our output, we use song popularity. This is again a number generated through Spotify algorithms and is on a scale from 0 to 100, 100 being the most popular. Here's some of the raw data that we acquired plotted here. So on the x-axis, you see the input features, and on the y-axis, you see popularity. And this just shows that there might be some patterns that our model might be able to predict popularity from. So moving on.
So to describe our machine learning model a little bit, we used a neural network with 4 hidden layers. What's important to note is that the size of the hidden layer cascades downwards as you traverse through the neural network. One thing to note is that we use a ReLU activation for both our input and our hidden layers. This proved to be very helpful for us. Our output was a sigmoid function, and this was useful because of the nature of our output, which was between 1 and 100. And that was scaled down to between 0 and 1. And within our deep learning model, there were a lot of things that we tried, but in the end, what we ended up using was mean squared error as our loss function, ReLU and sigmoid for activation function. We ended up using stochastic gradient descent as the useful optimizer. And for our hyperparameters, these all were tuned until we found values that seemed to be reasonable. And our initialization was He initialization. So for our results, we would have preferred to have received more state-of-the-art results, and these did not compare as well with what was seen in the literature. We believe that this was because our data was not vast enough, and if we were able to pull more data, perhaps we would have been able to detect a more valid signal between our audio features and the song popularity. Thank you.